In Lesson 6.5, we're going to look at logarithms and the properties that go with them. So here you'll see not only our essential question, like using our properties to simplify and solve logarithmic equations, but we're also looking at the properties. And basically our product property says that if you are adding like-based logs, you can write them as one product. So we'll see these examples here in a second. Or same thing with the quotient one. If you're subtracting like-based logs, then you would have division going on. That's our quotient there. And then finally, the power property. If you have a log base of some variable or number to a power, that power can come down out front here. So let's take a look at some examples. They're pretty easy to apply. We just ask you to identify which ones you're applying. With the proving of these, if you look in your packet answer key or in your class, your teacher will go through them. It's kind of nice to be able to know how these work or why these work, but for video time's sake, we're not going to go through the proofs now. We'll just use these properties. So here we have log base 5 of a squared b to the 7th. We can expand this as our log base 5. Now, because we see multiplication in here, we know we can write it as a sum. So a squared plus log base 5 of b to the 7th. But now we're going to also apply, so this would be what we call the product property. If you're asked to explain why you did that, it's because of the product property. If you ever have a product, then you can rewrite them as the sum of those separately. But also we're going to use the power property. And what that says is if you have this power here, you can bring it out front. So we could have 2 log base 5 of A plus 7 log base 5 of B. Right now, we're not really solving. We're just rearranging and rewriting these with our properties. So on B, we have division. And again, it doesn't matter if it's log or natural log. Remember, natural log is basically like log base E, so we can treat it with these same properties. So since I see division, I can write this as the natural log of 25 minus the natural log of 3. One other way, it's not probably necessary, but I suppose they could consider this as the natural log of 5 squared minus the natural log of 3. Now I'll note here that this was the quotient property. And then that's because we had a quotient, so I wrote it as subtraction. But now I'm going to use that power property. And I'm going to let this power come down front. So I'd have 2 natural log of 5 minus natural log of 3. Again, it might be a little confusing because normally you might be okay with just this 25 here. And this isn't wrong. That does properly express the quotient property there. But if you can rewrite this as a power, we can even kind of drag it out more, you might say. So you may want to try these try-its and look at the answer key from your teacher's website. So now they give us an expression, and it's kind of the drug out version here. We want to condense it as a single logarithm. So we're going to use those properties. What I notice here first is I have a number out front. Remember, by the power property, we can bring those up as an exponent. So this one would be log base 4 of m to the 4th plus log base 4 of m to the 3rd. And this one doesn't have a coefficient out front, so I'll just leave it. But this was all moves because of the power property. Now I'm going to use those quotient and product ones. So because I have an adding sign here, that's going to indicate my product property. So I could rewrite this as log base 4 of m to the 4th times m to the 3rd. And I'll just bring down this log base 4 of p. Now I do know m to the 4th times m to the 3rd. I add those exponents. So I would have log base 4 of m to the 7 minus log base 4 of p. And that wasn't a property. That was just the rule for multiplying like bases with the exponents. But then finally, with subtraction, I'm going to use the quotient property. And that's going to be that I have the same log base 4. M to the 7th will be on the top divided by P, because when I see subtraction, I can do the division. And this is our single condensed logarithm. Again here, I see that I have the number out front, and natural logs are going to follow those same properties. So by the power property, I would have the natural log of 2 to the 3rd minus the natural log of 5 squared. And you might wonder, do these have the same bases? They do. The reason we can apply this log property is the base of natural log is e. So since they're the same, we can do these properties. Then finally, I'm going to do the quotient rule here because I have subtraction. So I would have natural log of 2 to the 3rd over 5 to the 2. Now I am going to take 2 to the 3rd, and I know 2 times 2 times 2 is 8, over 5 squared is 25. So I just used the number operations, 5 squared and 2 to the 3rd, to give me my final answer here. Again, check your answer key for extra practice on the triads to write those as a single logarithm. One last part of section 6.5, we kind of want to go back to writing how we would write an exponential as a logarithmic form or vice versa. When we have, it says, let's solve this equation. There is something called a change of base property, but we're not going to cover it right now. And so we're just going to think about this, our base to the power of x equals 7, and rewrite it as a log. So I would have my 2 is my little base there. So I'd have log of 2. My 7 goes here, and my x goes here. So we're just going to type this into our calculator. And so if we use Desmos to do that, we would have that our x is approximately 2.807. So we've solved ones like this before. Just in a side note, say you're in a future class, it is kind of ironic, believe it or not, that this is actually the same as taking log of 7 divided by log of 2. So you might see that in the future, but we have handled things like this before, so since you've seen it, let's solve it like we always have.